Good morning, good evening, and good afternoon. We'll get you in here, get you learning soon. Everybody here is doing good. Um, I run out of things that rhyme with noon. Hi, everybody. This is Mr. P. Today we're going to be doing our guided notes for section 10.4. For secondary math 3, nope. Secondary math 2, nice try. Good mathing, Mr. P. And that's inscribed angles and polygons, so away we go. So first, let's do some definitions here. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. That is, an inscribed angle would be angle ABC. That's an inscribed angle because it is an angle whose vertex is on the circle and whose sides contain chords of that circle. An intercepted arc is the arc that lies between such an angle. Subtend: if the endpoints of a chord or an arc lie on the sides of an inscribed angle, then the chord or arc is said to subtend the angle. Huh? The endpoints of a chord or arc lie on the sides of an inscribed angle. That is, arc AC subtends angle ABC. Okay? And then also the line AC subtends angle ABC. An inscribed circle is a circle inside of a figure, really, but in a particular one, a triangle. So the circle is tangent to the three sides of the triangle. Technically, the three sides of the triangle are tangent to the circle, but well, that's okay. And a circumscribed circle is a circle such that all the vertices of a triangle lie on the circle. So the measure of an inscribed angle theorem. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. That is, whatever arc AB is, angle D is half of that. Another way to think of it is that arc AB is twice the measure of angle ADB. That one makes the more sense to me. I'm going to have you write that down too. The measure of arc AB is twice the measure of angle, in this case, we could just call it angle D. The inscribed angles with the circle theorem, that means since that's true, it also turns out that if two inscribed angles of a circle intercept the same arc, then the angles are congruent. And that might look really funny for some of these, like if this angle that I just created that goes through A goes to AB, that has the same measure as angle D and angle C, which seems crazy, but it's true. Inscribed right triangle theorem. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of a circle. Conversely, if one side of an inscribed triangle is the diameter of a circle, then the triangle is a right triangle, and the angle opposite the diameter is a right angle. That is to say, if this is 90 degrees, that means that this the arc cuts out 180 degrees, which makes it a semicircle, which makes this the diameter, and then it turns out that the reverse is true. Inscribed quadrilateral theorem. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. D, E, F, and G lie on circle C if and only if all those are, that's all true. D, a measure of angle D plus the measure of angle F is 180, and the measure of angle E plus the measure of angle G is also 180. And that makes sense, because basically, since that cuts out half the circle, more on that in a bit. More on that in a bit. More on that in a bit. Measure of an inscribed angle theorem. Find the indicated measure. Now remember, I told you that the arc is twice the measure of the inscribed angle, which means that the measure of angle K is half of the measure of arc JL. And since JL is 40 degrees, the measure of angle K is 20 degrees. I'm going to put my answer down here. Measure of angle K equals 20 degrees. The arc DF. So the opposite is true. Since DEF, angle D is 72. Double that, and you get the measure of this arc. So the measure of arc DF is equal to 2 times the measure of angle E, which is 2 times 72, which is 144. That is, the measure of arc DF equals 144 degrees. Okay, measure of arc ST, that's this little guy right here. Well, let's see here. So we've got a diameter here, which makes that a right triangle, by the way. Why? Because if this is 180 degrees, this has got to be 90, which means that this measure here, well, 180 degrees is what goes into every triangle. Take away the 90 degrees that we know because that's a diameter. Take away the 61 degrees we've been given. And 180 minus 90 is 90, and 90 minus 61 is 29 degrees. It almost wants to be a 30, 60, 90 triangle, but not quite, which means that the measure of angle U, and I guess SUT, is 29 degrees. And since the arc is double that, 29 degrees times 2 is 48? 58. So the measure of arc ST is equal to 58 degrees. There you go. Describe angles in a circle theorem. I just named two sets of angles that are congruent to each other. That is, we need to find two angles that cut. What's that? Why don't we just use the vertical angles? Nah, that's clever, but not quite what we're trying to learn here. Besides, they didn't give us a point there, so let's do it without naming any extra points. You clever so-and-so. So we're going to imagine this arc AD. What angle cuts out arc AD? Well, angle C does. Is there any other arc that's cut any other angle that cuts out arc AD? Yeah, it's angle B. So angle B is congruent to angle C. Let's see if there's another arc we can find. Well, oh, look at this. Arc BC is being cut out by angle D and angle A, which means that angle D must be congruent to angle A as well. Same story over here. Look at S and R. Oh, wait, is that a multiple choice question? Holy moly, I can't believe it. In the diagram, which statement is true? SPR is congruent to PSQ. Well, SPR, this angle, is it congruent to PSQ? Maybe. They look it, but the truth is we don't know because they don't cut out the same sector. The same arc, excuse me. In fact, actually, when you look at the arcs they do cut out, you can see that they almost certainly are not. So we don't know, but according to the picture, likely not. RQS, R to Q to S, this angle, and RPS. Do those two cut out the same sector? Yes, they do. And so that is true. Those have to be the same measure because they cut out the same sector. Same arc, excuse me. Let's just make sure this isn't a trick question where they're multiple. Whoa, hey, whoa, that was odd. Okay, here we go. RPS, R to P to S, that's that guy, and PRQ, P to R to Q, we don't know, probably not. PRQ, P to R to Q, and SQR, S to Q to R, no, probably not. However, PRQ is congruent to QSP, which is what my daughter calls crisps. Quisp. Inscribed angles in a right triangle theorem. Use the diagram to find the indicated measure. The measure of angle A. Well, that's got to be a right angle because BC is a diameter. So since it cuts out a 180-degree arc, it's going to have a measure of 90 degrees because it's half of that. The measure of angle C then, well, if it's 180 degrees for the whole triangle, we take away the 28 and we take away that other 90. And so 180 minus 28 minus 90 comes out to be 62 degrees. 62 degrees. Write that down in case it's helpful later. The length of BC, well, I guess that's the diameter there. Since this is a right triangle, I can solve it. Leg squared, 7.3 squared, plus leg squared, 3.9 squared, is equal to the hypotenuse squared. And I'm just going to call that x, if that's okay. 7.3 squared plus 3.9 squared, 68.5. Sure. Actually, it looks like x2, x squared. And then we take the square root of that, which means that the measure of BC is approximately 8.276. I like thousandths if they don't say 8.276. How about the arc of AC? Well, the arc AC is being cut out by the angle 28, and so that's equal to double 2 times 28, which is 56 degrees. And the arc AB, again, is being cut out by a 62-degree angle, and so we do 2 times 62. That's 124 degrees. Easy peasy, lemon squeezy. Inscribed quadrilateral theorem. Find the value of each variable. So that is, the inscribed quadrilateral theorem states that opposite angles in the quadrilateral here are going to be supplementary. That is, 113 plus the measure of angle y is equal to 180. So 113 plus y equals 180. Take away 113. And 180 minus 13 means that y, 180 minus 113 is 67 degrees. So y equals 67. Notice it already has the degrees, which is why I left the units off. X, same story, except now we're going to do that 70 plus x equals 180. Subtract 70 from both sides. And you're going to do 180 minus 70, and that's 110. Okay, so this one's a little bit trickier, but it's okay. I know that 63, the measure of angle A, plus the measure of angle C, which is 3x, must be equal to 180. So now it's just multi-step equations instead of just a single stepper. And 180 minus 63 is going to be 117. So 3x equals 117. But I'm not done yet because I need to divide both sides by 3 to get what x actually is. And x is equal to 39. As for y, again, I know they add up to 180, so 4y minus 1 plus 65 equals 180. Combine like terms, 4y plus 64 equals 180. Subtract 64 from both sides. That was odd. And 180 minus 64 is equal to 116. So 4y equals 116. Divide both sides by 4. Is that 29? It is. I got one. Yay! Which means x equals 39 and y equals 29. Which means x equals y plus 10, but that's not something anybody asked for. I don't know why I thought about that.